All right, I'm going to talk about two-way tables, which we haven't talked about for a while. But hopefully you kind of remember some of this stuff. The idea behind two-way tables. Oh, and you know what? Is that you're looking at more than one piece of dividing data, right? So this one's actually pretty complicated to just make up like this, but I will try. Let's say that we're asking a bunch of people if they like math better or English better, which is a stupid question, actually. I hate that question because I like math and English. I mean, I like all subjects, but maybe that's just me because, you know, I'm me. And let's see if we're comparing freshmen and seniors, right? And let's see, we'll say like 10 seniors said that they liked math. That's what that means, right? It's the inner, like, think like it's meaning two things, math and seniors. So 10 seniors said they liked math, 20 freshmen said that they liked math, 15 freshmen said they liked English, and 30 seniors said that they liked English, right? If you remember back when we talked about this sort of stuff, these are all joint relative frequencies. They're telling us two pieces of data, like the 20 is about both freshmen and people who like math. Over here is where we'll have our marginal relative frequencies, which are the combinations, right? So we can go ahead and all we do is we add these up. So we'll do 20 plus 15, that gives us 35. And that means that's the total number of ninth graders, right? We'd asked 35 freshmen. Same thing with the next row. We can say 10 plus 30 is 40. That means they asked 40 seniors. We can go the other direction, right? So let's say we're looking at the 20 and the 10. That's going to tell us that 30 people that they asked liked math. Let's say we look at the 15 and the 30. That's going to tell us that 45 of the people that they asked like English. The last number here, if you remember, is the total number. This one's 75. You can see that by either adding together the total here, 35 plus 40, or the total here, 30 plus 45. Either way, you get the same answer. And so like there's a couple of things. The 75 is the total number of people that they asked in general, right? And the 75 is what you would divide by when you're trying to calculate relative frequencies. So let's say I ask you, hey, what percentage of students that they interviewed were liked math? So you would use the 30 from the total number of students who liked math, and then you would divide that by the 75 because that's how many students they asked, right? And then you would get that as a decimal. Let me go ahead and use my calculator. So we're doing 30 divided by 75. I have to go make dinner. Oh, sorry. We're getting 0.4. Now, as a percentage, remember, multiply that times 100. So we're getting 40%. You can also do joint relative frequencies, which would be looking at like how many of the people here are seniors who liked English. In that case, you're going to use this 30 right here, right? Now here I use this because I don't want to do more calculator work. You could also say, hey, this is also going to be 0.4. So another 40%. Sure, 40% of the people like math, but 40% of these people were seniors who liked English. So that's just interesting. Remember, there's also a conditional relative frequency where you don't use the total number of people. Instead, you say something like, okay, of all the people who like English, how many of them are seniors? So 30 seniors liked English, but all the people who liked English aren't the 75 because some of those people like math. Instead, the 45 right here, this is the number of people who liked English, or this is the total number of people who liked English. And this percentage is giving us 0.66 or 0.667. So converting that to a percentage, because that's a decimal, we'd get 66.7%. Hopefully you kind of remembering this stuff as I was going through it. If you have questions, please